Welcome to the building blocks of code. Look, whether you're trying to build the next big AI, analyze massive data sets, or honestly, just kind of figure out how the digital world ticks under the hood, you are absolutely in the right place. Today, we're unpacking the true foundation of Python programming, taking this whole complex world of code and breaking it down into really simple, progressive blocks. But before we even write a single line of code, we've got to talk about this massive communication gap. Think about it. We think and speak in these rich, complex languages, like English, right? But computers, they literally only understand machine language, just an endless sea of zeros and ones called binary. So how do we actually cross that divide? Well, programming is the ultimate bridge. It's how we take our human ideas and translate them into instructions a machine can actually execute. Okay, here's our game plan for today's explainer. We're going to hit the language of machines, tools of the trade, rules of the road, dynamic data, mastering strings, and finally, type conversion. Let's get right into it. Section 1, the language of machines. We are kicking things off with the absolute basics of Python. Here's the thing. If you just feed Python directly into a computer, it's going to have absolutely no clue what you're saying. We need a middleman. Enter the translator. This is what takes our high-level, basically English-like Python instructions, and seamlessly converts them into the exact binary code the hardware actually gets. It does all the heavy lifting, so we can just focus on, solving the actual problems. Moving on to Section 2, Tools of the Trade. This is where we look at functions and modules. Imagine buying a brand new smartphone. Right out of the box, it comes with pre-installed apps, right? Your camera, your messages. In Python, these are what we call built-in functions. Stuff like print, to get text on your screen, or input, to actually ask the user a question. They are just always there, ready to go. But what if you want to use WhatsApp? Well, you've got to download a new app. It's the exact same thing in Python. When you need extra advanced features, like, say, calculating a square root, you bring in modules. You literally have to import them to unlock those extra capabilities. Section 3, Rules of the Road. Time to talk about navigating errors and identifiers. Running your Python code is actually a lot like driving a car down the highway. If you break a basic traffic rule before you even get going, like, you forget to close a bracket or misspell a keyword, the car won't even start. Python throws up a roadblock immediately. That's a syntax error. But what if your grammar is perfect? You follow the rules, you start the car, you're driving along, and then the engine just completely explodes mid-journey. That, my friends, is a runtime error. A classic one is the zero division error. The code looks totally fine, but the split-second Python tries to divide a number by 0 while it's actively running, the whole thing crashes. So part of avoiding those crashes means strictly following the naming rules for identifiers, like when you're naming your variables. First rule, no reserved Python keywords. Things like true or false are totally off limits. Second, you absolutely cannot start a name with a number. Third, no special characters. No hashtags, no @ symbols, literally only the underscores allowed. And listen to this part carefully. Python is strictly case-sensitive. An uppercase A and a lowercase a, Python treats those as two completely different things, no exceptions. Section 4, Dynamic Data. Let's see how Python handles different data types. Python has this amazing feature called dynamic typing. You don't have to announce to Python, hey, this variable right here, it's only for numbers. You don't have to do that at all. Instead, a variable in Python is like a reusable shopping bag. Today, you might drop an integer into it, like the number 50. Tomorrow, you can just swap that out and put a text string in it, like the word books. Python seamlessly figures out the data type behind the scenes based completely on whatever value you just handed it. And it gets better, because Python data types have what's called unbounded size. They are incredibly resilient with memory. In older programming languages, if you tried to squeeze a massive number into a fixed-size memory container, it would just overflow and crash your entire program. Python doesn't play that game. Its variables are kind of like a balloon. As you pump more and more air into it, or in our case, assign it some insanely huge number, Python dynamically expands that variable's memory size right on the fly, so your program just keeps running without a hitch. All right, Section 5, Mastering Strings. Let's dive right into text and sequences. So internally, Python handles words a bit like a row of apartments. Every single letter gets its very own specific address. Take the word Python. The system of addressing these letters is what we call indexing. We can count forward using a positive index, which, and this is super important, always starts at 0. So P is at index 0, Y is at 1, right up to 5. But Python also gives us this brilliant shortcut, negative indexing. Say you just want the very last letter. You don't have to count all the way from the beginning. You just ask for index -1, and boom, you've got the N. -2 gives you O, and you can just work your way backward like that. Now we can actually leverage those addresses to pull specific sequences right out of our text. This is a real game changer called string slicing. The setup is simple but super powerful. Start, stop, and step. First up, you pick a start index, and that letter is included. Next, you pick a stop index, but watch out here. This stop point is exclusive. That means Python stops exactly one spot before this index. And finally, you have the step value, which is basically just how many jumps you want to make. It defaults to 1, but if you bump the step to 2, you'll skip every other letter. And actually, if you set it to -1, you'll literally reverse the entire string. And our final stop, Section 6, Type Conversion, how to magically change data types. Sometimes your data just isn't in the right format to do what you need, so we have to transform it. There are two ways this happens. First is implicit conversion. This is basically Python being smart for us. If you add an integer, say 13, to a float with a decimal like 4.5, Python just automatically upgrades the answer to a float, 17.5. It does this entirely on its own, so you don't lose any of that precise decimal data. But then there's explicit conversion. That's when you have to step in and really force the issue. If you try to add the integer 10 to a text string of the number 5, Python is going to throw a fit. It'll give you a type error because it cannot mix math and words. So you have to explicitly use a built-in function to convert that text string into an integer first. Once you do that, the program can add them up perfectly. And there you have it. You now understand the language of machines, the tools in your toolkit, the rules for driving safely, the pure flexibility of dynamic data, the power of string slicing, and the mechanics of type conversion. Honestly, you've just massively leveled up your understanding of Python's core engine. So now that you're holding all these foundational building blocks in your hands, the real question is, what's the very first program you are going to build? Keep exploring, keep building, and I will see you in the next explainer.